Hi, here we have a problem on parametric equations. We have two parts. The first part is we have to eliminate the parameter from the given set of equations. And the second part is we have to sketch the graph of the curve. Okay, let's do the first part. Here in the given parametric equations, theta is a parameter and we have to eliminate the parameter theta and we have to give the equation in terms of the variables x and y. Okay, to eliminate the parameter theta, I'm going to solve for cosine theta from the first equation and for sine theta from the second equation. Okay, let's try the first equation, that is x is equal to 4 cosine theta. So to solve for cosine theta, I have to get rid of this 4 which is multiplied by cosine theta. For that, I have to divide both sides by 4. So here 4 will cancel out. X over 4 is equal to cosine theta. Now let's solve for sine theta from the second equation. So y is equal to 9 sine theta. To solve for sine theta, I'm going to divide both sides by 9. 9 will cancel out. I get y over 9 is equal to sine theta. Okay, now I have solved for cosine theta and sine theta from the given parametric equations. Cosine theta is equal to x over 4 and sine theta is equal to y over 9. Okay, we know the basic trigonometric identity, that is sine square theta positive cosine square theta is equal to 1. Okay, here sine square theta can be written as sine theta the whole square positive, cosine square theta can be written as cosine theta the whole square is equal to 1. Okay, we know that sine theta is equal to y over 9. We have over here. So we can substitute y over 9 for this sine theta. Then we get y over 9 whole square. And we know cosine theta is equal to x over 4. So we can substitute x over 4 for cosine theta. So x over 4 whole square is equal to 1. Okay, so here 2 is a common exponent for the fraction y over 9. So this exponent can be taken for numerator and denominator. Then I'll be getting y square over 9 square positive. The same thing I can do for this one. X square over 4 square is equal to 1. Okay, the value of 9 square is 81 and here x square over the value of 4 square is 16. Okay, we can write the variable x at first. Then I get x square over 16 positive y square over 81 is equal to 1. So we have eliminated the parameter theta and we got the equation in terms of for the two variables x and y. Actually, this is an equation of an ellipse. That is, if we sketch the graph of this equation, we'll be getting an ellipse. Okay, now let's do the second part of the question. That is, we have to sketch the graph of the curve for parameter values 0 less than or equal to theta less than or equal to pi. So that is the minimum value of the parameter theta is 0 and the maximum value is pi. And theta can be equal to 0 because theta less than or equal to 0. That means theta, the value of theta can be equal to 0 or it has to be greater than 0. And also theta can be equal to pi or it has to be less than pi. Okay, from 0 to pi, we can take some known values like for known angles for theta, and we have to plug in those values for theta into the given parametric equations. Then we have to get the points in terms of Cartesian coordinates. That is, we have 0 is the minimum value for theta and pi is the maximum value for theta. We can take multiple values for theta between 0 and pi, but I just consider only one known angle that is 90 degree or pi over 2 radians between 0 and pi. So since theta can be equal to 0, I start taking theta is equal to 0, theta is equal to pi over 2 and theta is equal to pi. That is, I'm going to plug in theta equal to 0 into the given parametric equations. Then I'll be getting x is equal to 4 cosine 0, comma y is equal to 9 sine 0. Okay, we know that the value of cosine 0 is 1. 1 times 4 is 4. So we get x is equal to 4. And y is equal to, the value of sine 0 is 0. 0 times 9 will be 0. So the point is going to be 4, comma 0. When theta is equal to 0, the point of what we get is 4, comma 0. So actually this is the x coordinate and this is y coordinate. Now we got the point in terms of Cartesian coordinates. Okay, now let's check the second value for theta. That is theta is equal to pi over 2. Then we get x is equal to, now we have to plug in theta is equal to pi over 2 into the given parametric equations. That is 4 times cosine pi over 2. Y is equal to 9 times sine pi over 2. So the value of cosine pi over 2 is 0. 0 times 4 is 0. And the value of sine pi over 2 is just 1. 1 times 9 is 9. So we get x is equal to 0 and y is equal to 9. So the second point, I mean, when theta is equal to pi over 2, we get 0, 9. Okay, let's take the third value for theta. So let's plug in theta is equal to pi into the given equations. I mean, given parametric equations, that is x is equal to 4 cosine pi, y is equal to 9 sine pi. So the value of cosine pi is -1. -1 times 4 is -4. The value of sine pi is 0. 0 times 9 is 0. So we get -4, 0. So we get 3 points in terms of Cartesian coordinates. When theta is equal to 0, we get 4, 0. When theta is equal to pi over 2, we get 0, 9. When theta is equal to pi, we get -4, 0. Okay, we have to plot these 3 points 4, 0, 0, 9 and -4, 0 on a xy plane and connect all the 3 points by freehand curve. Okay, now we can plot the 3 points 4, 0, 0, 9 and -4, 0 on a xy plane. So here 4, 0 that we have over here on the x-axis, and I'm going to take a filled circle over here because I got this point 4, 0 when theta is equal to 0, and also in the information of the question, theta can be equal to 0 or theta has to be greater than 0. So theta can be equal to 0 means like the point what we get for theta is equal to 0 must have a filled circle. And also here we have a question like that is if we have 0 less than theta less than pi, what do we have to do? So very simple. Again, we'll be doing the same thing. That is, we'll plug in 0 for theta into the given parametric equation, and we'll be getting the same point 4, 0. But this time you have to take an empty circle at 4, 0 because this time theta cannot take the value 0 because the value of theta has to be greater than 0. So if you have less than or equal to, the point corresponding to this value must have a filled circle. If it is just less than, then the point corresponding to this value must have an empty circle. But in our problem, we have less than or equal to, so the point what we have for theta is equal to 0 must contain a filled circle. Okay, the second point is 0, 9. It will be on the y-axis because the x coordinate is 0. It will be here, 0, 9. Okay, the next point, the last point is going to be -4, 0. Since the y coordinate is 0, it will be on the x-axis. Since this is the ending point, we have to decide whether we are going to have a filled circle or empty circle. So actually, we got this point -4, 0 when theta is equal to pi, and we have less than or equal to over here. So we must have filled circle at the ending point. So now we just have to draw the curve by freehand curve. Okay, this is almost half of the ellipse because we start from theta is equal to 0. 1 second. This is -4, 0. When theta is equal to 0, we get the point 4, 0. When theta is equal to pi over 2, I get the point 0, 9. When theta is equal to pi, I get the point -4, 0. So the starting point is 4, 0, and then we go to the point 0, 9. From 0, 9 to we move to the point -4, 0. So I must indicate the direction because there is an instruction in the question, indicate the orientation of the curve. That means we have to indicate the direction of the curve. From where we start, where we are going, and how to show the direction of the curve. I think everyone can understand this. Thank you.